Okay, so let's continue our presentations. Let's look at changes of states of matter. We know that we have 3 states of matter: gases, liquids, and solids. There's also the 4th one that we hinted on just briefly, and that was the plasma state. In our presentation, we are going to focus on the 3 and what happens if one a substance in one state of matter changes into the other state. Okay, so what types of changes do we call them? Do we call them physical? Do we call them chemical? And why do we call them chemical or physical? Okay, what are the defining characteristics and what are the examples in each of these types of changes? Now, in chemistry, we are interested in how matter behaves under different conditions. That was the definition of chemistry that we had. And therefore, that behavior is basically the properties. When we talk about properties of a substance, we're talking about how that substance behaves under different conditions. Okay? Under different media, under different changes in terms of whether there's a catalyst, whether there's no catalyst, whether there's a change in temperature, whether there's a change in pressure, whether there is change in terms of size, or whether there is change in terms of the medium, a lot of things. So we are interested in the properties. That is what chemistry is all about. Okay? So for example, we all know that water is actually tasteless, odorless, and is colorless, as long as it is in the purest form. Okay? We also have properties like we know it boils at 100 degrees centigrade. Those are some of the properties of water. So in chemistry, we are interested in these properties because if we have a substance that we don't know, but if it has the following characteristics, say no, that is water, no, that is sodium, no, that is copper. Okay, that's why we need to know the properties of all these chemicals so that we can be able to identify them. Okay, yes. So these properties are actually divided into 2, what we call chemical properties and physical properties. These are actually interlinked. In your chemistry, you actually be looking at physical properties first and then followed by the chemical properties. That is not by accident. Why? Because the physical properties in a way explain some of the chemical properties. Okay, the physical properties in a way explain some of the chemical properties. So that is why we usually start by describing the physical properties. So what are these physical properties? These are actually properties that allow us to identify a substance without altering its chemical composition. Okay, for example, when we say that water boils at 100 degrees centigrade and freezes at 0 degrees centigrade, the composition remains the same. Okay, but when we talk about chemical properties, these are things that will alter the composition of the substance that we are talking about. Okay, so using water, for example, if water reacts with a metal, often a gas called hydrogen will be produced, and another compound will be produced. Therefore, that is a chemical property of water because what you have formed is different from what you had initially. Okay, so that is what we call a chemical property. For a physical property, the thing remains the same in terms of composition. Okay, so we also look at 2 other terminologies that we use when describing properties of substances. We have what we call extensive properties. These are characteristics that depend on the amount of substance that you have. Okay, depend on the amount of substance that you have. Let us take the example of, for example, the intensive properties. Then perhaps this is what will help us understand the extensive one. So, for example, the behavior, the properties of water will remain the same. That is the test, the order, regardless of how much water you have. The test will be the same, right? Yes, the test of water will be the same. Whether you have it in 10 kilograms, 10 liters of water, or whether you have it in the bottle of 300 mils. The test of water will always be the same. So those are that test and the order. Those are intensive properties. That means that these properties don't change regardless of how much you have. And then for the extensive properties are the ones that will depend on how much you actually have. For example, the weight of the substance. If you have more of that substance, the weight will be higher compared to if you have less of that substance, right? Yes. So we said that matter can change from one state to another state, and these changes can be categorized into two: physical change or chemical change. We can also call them temporary change or permanent change, and we shall see why we use those terms. So let's start with the temporary change. If you have solid ice, okay, ice, and then you melt it to form water, that is a temporary change because the composition is actually the same. And you can get this water and turn it to ice as long as you lower the temperatures. That is what you call a temporary change. So a temporary change is actually reversible. And you don't form a new product. Okay? So things like melting the ice, burning the candle wax, vaporization of water, these are temporary changes. And we actually call them physical changes, just like the one we have here. And then when you have wood, burn it into ash, you can't turn the ash into wood. No, that is a permanent change. Okay? So with the permanent change, you create a completely new product and you cannot convert that product into what you had initially. So it is permanent change, and it's what we call a chemical change. So burning a paper, rusting of metal, burning of charcoal, heating of sulfur in the air, those are chemical changes and we call them permanent changes. New products are formed and the process is irreversible. That's why we are saying it is permanent change. Okay, so the key terms or the key differences: with a physical change, no new substances form. New substances form this side. This is reversible. You can get the ice from the liquid water. When you burn wood, you can't get wood out of it again from the ash again. Sometimes you have changes in the mass for chemical change. And then here you will not really have no heat energy is lost or absorbed when the change happens for physical changes. Here sometimes you have heat that is emitted or absorbed. Okay, so let's think about it again further. What happens with physical change is that it can alter how the thing basically looks like, the physical properties. That does not alter the chemical composition. That is something that we are stressing here. So when you have ice and melt it into liquid, this is a physical change, right? What you're basically doing is changing the shape and fluidity. That's what is changing. And these are physical things, physical properties that you can actually see with your eyes. But when you basically check the molecules in ice and the molecules in water, which is liquid, then it's basically the same. You have hydrogen, you also have oxygen. Then that's it. But the arrangement may change. Okay? And actually, you will have the volume actually changing. Okay? But the chemical reaction, on the other hand, you have entirely new properties, new products being formed with the new properties, new chemical properties. Okay, so for example, you burn this, the wood, you get ash. This ash here and this smoke, these are different from this. These two here are different from that. So that is basically for emphasis reasons. So you have matter changing from one state to another through different mechanisms. So remember, we have one state, solid, two, liquid, three, gases. We can have changes from one state to the other. The two major changes that are usually very important, easy to memorize or to think about or even explain. When you have a solid that changes directly into a gas, that is sublimation. Perhaps the first time you're hearing about it is just that you have some solids that can directly turn into gaseous state, and that process is sublimation here. Again, you have gases that can turn directly into solid. It's very possible, and that process is what you call deposition. Okay, and actually water can do that under certain conditions. Okay, the liquid and the gaseous water vapor turning into solid in certain conditions, that is possible. If you want to turn the solid into a liquid, usually you need to heat until you reach that point where the solid becomes a liquid. That's called the melting point. So the process is basically melting. And then when you have a liquid and you want to turn it into a gas, you need to heat it. And that happens. When you do that, you have evaporation. It evaporates into vapor. Okay? And then when you have a gas and you want to make it a liquid, you have to cool it, and that is condensation. Condensation process. And if you have a liquid and you want to turn it into a solid, you need to reduce the temperature, and that is also called freezing. Okay? So let's look at these terminologies. Perhaps there are some concepts that we can learn more as we explain them one by one. So melting is when you have a solid substance turning it into a liquid. You need heat. You need to heat that solid. When you heat that solid, the bonds that hold the solid particles together break and they loosen. Now they can move freely. Okay, so they can no longer be in a fixed position. So that means that they can flow freely. So that this explanation relates to what we saw in the arrangement of particles in solids. The particles in solids are closely packed together, held by strong forces of attraction. For you to melt it, you need to subject it, the solid, to high temperatures. You heat it until you reach the boiling point. At the boiling point, the bonds are broken and the particles move freely. That is melting, okay? Then we move to freezing. Freezing is the opposite of melting. The particles become held together, okay? So what happens with this is that the temperature, the liquid loses the heat energy. The particles no longer move freely. They become organized, forming a solid structure, okay? And these are the ice tubes. These are the ice tubes, okay, being formed. This is just an example. Vaporization is when you have the liquid or solid changing into a gas, okay, and it can happen through evaporation. Evaporation usually is when you have the water vapor, okay, being emitted from surfaces, okay. Basically what is happening here is that the liquid is transforming into a gas, which we are calling the water vapor here. Okay, even at room temperature, some liquids can still vaporize. Okay, but basically, the more you have heat, the more likely you will have vaporization happening or evaporation happening. Okay, and then at boiling point, this is when now the liquid is actually the particles are vaporizing at a very high rate. Okay, so at boiling point, the liquid vapor pressure is actually equal to what you call the atmospheric pressure, and this allows the bubbles of gas to form throughout the liquid. Okay, you only know that the liquid is boiling if you have these bubbles coming out. At that point, the liquid's vapor pressure is equal to the atmospheric pressure. That is something that we shall use later on in our calculations to do with gas laws. Okay, so boiling of water happens at 100 degrees centigrade, but you also have other liquids boiling, having their different boiling points. Okay, condensation, the opposite of vaporization. Here you have the liquid transforming, you have a gas transforming into a liquid. Okay, this happens when the gas actually loses heat energy and the particles no longer move freely. They just slow down and come closer, forming a liquid or liquid droplets. Okay, and then we have sublimation, which we said is when a solid turns directly into a gas without going through the liquid phase. Okay, you can have dry ice, which is actually solid carbon dioxide sublimating at room temperature. Okay, that means that the solid carbon dioxide can become gaseous carbon dioxide at room temperature, and that is sublimation. Okay, so that marks the end of this presentation where we have looked at the chemical and physical properties or physical changes of matter. We have noted that we have different processes that can allow a particular substance to transition from one state of matter to the other. This transition happens if, in most cases, when we have heat either being absorbed or when heat being lost. Okay, so when you subject heat to a substance, it can melt, it can vaporize. Okay, and then if you reduce the heat, you have condensation. Okay, and you can also have freeze, and we have looked at what this really means. We have looked at two concepts that are not very common. We have sublimation and deposition. We said that sublimation is concerned with the solid transitioning directly into a gas without passing through the liquid phase, and then with deposition you have the gas turning directly into a solid without going through the liquid phase. Thank you for listening.